paradigm, as in a paradigm shift, has been so abused as to become kind of a tired cliche. It's found on shelves of business books. You see it everywhere. However, when Thomas Kuhn first introduced the term in his book over 50 years ago, The Structure of Scientific Revolutions, the result was a revolution of the kind his very book described. The word paradigm in the modern usage points to a kind of worldview or perspective. So those who share a paradigm share a way of thinking about something, whether it be a way of conducting business or of doing science. Originally, however, the word meant something closer to what we now use the word exemplar. Paradigm was a word that you found in Latin grammar books. It was the template that you used to conjugate verbs. So the template conjugation was taken as a paradigm. You could follow it for conjugating all sorts of other verbs that shared the same pattern. Kuhn broke the understanding of science then at the time. Originally, the view of science was as being a largely cumulative affair. One scientific result builds on another, you get new experiments, new data, and knowledge slowly progresses. Now, it's progressing to some final state of truth and perhaps never reaching it, but it's always inching closer. It's always going in that direction of truth, never backwards. In Kuhn's study, science as it actually was practiced didn't work this way at all. Instead, it was an oscillation between normal, commonplace expansion of existing theories and results, and revolutions whereby entire fields were upended and replaced with a new model from the ground up. So to understand this oscillation between normal science, where you're continuing this cumulative progress, the stereotype we have of all science working this way, and revolutions, you need to understand what paradigms are, more specifically what Thomas Kuhn meant when he was talking about paradigms. So Kuhn rarely pointed to some direct, really easy to recognize object as saying this is the paradigm that he's trying to describe. The closest reference he made was something kind of like the problems you find in textbooks. These represent well-defined problems with well-defined solutions, which are seen as being definitive of how that field views itself. So if you're studying physics, for instance, the paradigm is embodied by Newtonian mechanics of balls rolling down inclined planes, pendulums swinging at constant periods, or celestial objects following elliptical orbits. And these kinds of problems are taken to be the paradigms of the field because those are the core, central, focal examples of how the field views itself. More complicated examples, for instance, balls rolling down hills with grass that has friction and all sorts of wind and turbulence, is seen as being outside or on the fringes of that paradigm rather than in the center of it. So this view, prior to Kuhn, has been that science works via accumulation. New experiments, new theories, new facts are just slowly added to the cruft of scientific knowledge. Paradigms, in contrast, don't work this way. Instead, they provide focal points to indicate the kinds of things that exist in the world, how they relate to one another, and what sorts of problems and questions science aims to solve. A good way to illustrate this difference is to look at the divide between Aristotelian mechanics and Newtonian mechanics. So Aristotle, that Greek philosopher that we all know, believed that rocks sink and bubbles rise because each seeks their sort of natural resting place in the world, with rocks on the bottom and air on top. Newton, in contrast, argued that there's a force of gravity attracting rocks, well, and air for that matter, to the earth, and that momentum will be conserved. So now, consider between these two paradigms, consider the pendulum. So in Newton's day, it was known that a pendulum, once it started swinging, would continue to swing at that same period, and the closer it approached ideal conditions, meaning less friction, less mechanical resistance, less air getting in the way, it would keep swinging forever. Kinetic energy becoming potential and then back again. Conservation. Kuhn argues that the Aristotelian view of a pendulum wouldn't have been to see it this way. That Aristotle didn't consider pendulums because in that paradigm they would have been a strange, complicated object. The stone or the weight of a pendulum was always going to its natural resting spot at the bottom. It was just taking a really windy, roundabout way of getting there. And this doesn't just mean that Aristotle was wrong or that he was being pig-headed about not considering the real truth of how the pendulum worked, but rather that for Aristotle, rocks just falling to the ground when we drop them was the paradigmatic case, and the pendulum was a sort of weird example. Just as in Newtonian mechanics, things that have lots of friction and resistance and lots of other complicated details were something that is believed to be solved by the paradigm or believed to be understood by Newtonian mechanics, but maybe not something that's actually tractable, that you can actually figure out with a pencil and paper to know what's going to actually happen with it. So the friction and mechanical resistance, which are nuisance terms for the Newtonian, are the essential elements for the Aristotelian, that they believe that objects slow down after you push them because friction and resistance are taken to be part of the essential part of the paradigm rather than being some additional correction figure. So by this view, Kuhn argues that science didn't just get an accumulation of new facts when it went from Aristotle to Newton. It wasn't simply that Aristotle just had the wrong theory and Newton got the right one, but rather the very types of problems which were considered to be paradigmatic or central changed in this revolution. In one, the constant slowing down and dissipation of momentum was central. In the other, the perpetual pendulum, the continuing movement of the planets around the sun was considered to be the paradigm. In Kuhn's view, scientific revolutions, like political ones, are a violent affair. They're not merely supplanting the current regime using the tools and structures that currently exist. Instead, they're a rejection of those tools, and they often supplant the new theory by breaking the accepted practice of the old one. Max Planck, one of the fathers of quantum mechanics, was famous to have said, "A new scientific truth does not triumph by convincing its opponents and making them see the light, but rather because its opponents eventually die, and a new generation grows up that is familiar with it." Now, this quote is often used as evidence to point out to the inherent stubbornness of human nature. However, as Kuhn argues persuasively that at least in the interim period, where a new paradigm is nascent, when the rules haven't been figured out and the conversion has not been fully accepted, the conversion from the old regime to the new one is usually not an empirical matter. Most new theories actually have scant empirical evidence in their favor, and in the beginning, the old theory, however flawed, has substantial things that it explains which the new theory doesn't seem to do so. For instance, when Copernicus suggested a heliocentric model of the solar system, this flew in the face of the Earth-centered Ptolemaic astronomy. However, during Copernicus's time, his new theory didn't seem to make predictions any better than Ptolemy's did. Now, part of this is, of course, due to an unfair advantage. The old astronomers using the old Earth-centered system had hundreds of years to kind of jury-rig the system to integrate bizarre facts to make it work. It was getting increasingly cumbersome and complicated to make correct predictions with Ptolemy's system, but it did work, and it often made predictions better than the new Copernican system seemed to make. So it's not simply the case that theories are overthrown because, well, the new one is just better. It just works better across the board. Sometimes it works better on a certain subset of problems, but many other problems it doesn't have answers for yet. So it's worth noting that the conversion isn't primarily because one theory neatly subsumes the other and simply is a better upgrade, the cumulative process of science as we typically understand it. Rather, very often those jumping on a new paradigm are forced to leave many facts and things that were previously known behind. Those switching from phlogiston to atomic chemistry, for instance, had to abandon how the former theory, quote unquote, explained why metals share so many properties but with each other, but not with their ores. So this may seem like a weird needling. After all, we know that Newton's theory of mechanics works better than Aristotle. He was more correct. And it's not that Aristotle explained motion. Newton's theories expect that friction and dissipation due to complex interference will occur. So it's not that Aristotle's theory works better in domains with friction and Newton's works better without. We expect that Newton's theory will be able to handle all those cases. And it's not that phlogiston explains certain chemical properties because the theory was false. It was merely jury-rigged to pattern match the available evidence, and atomic theory, properly understood, explains those same chemical properties much better. But this, Kuhn argues, is partly the danger of seeing from within a paradigm. Of course, from within a paradigm, earlier paradigms are simply wrong. They were incorrect theories that needed to be replaced. And now we have much better evidence that the paradigm we use today is better. So science does progress. It is true that Newton's theory was better than Aristotle's and that atomic chemistry is better than phlogiston. Few people deny the progress of science, and Kuhn's argument is not that science is merely all relative and some cultural fad that certain theories are better than others. However, it's important to note that the interim period, so during this process of revolution, when a field goes from one paradigm to another, is a sensitive time. The new theory often doesn't explain many of the things that were previously understood by the old theory. The process of revolution tends to rewrite history, making the switch between paradigms seem like an ordered succession, an ordered ascension to the throne of a new and better theory, rather than the violent overthrowing of a previous way of looking at the world. Science, according to Kuhn, progresses in a process of three distinct phases: normal science, crisis, and revolution. Normal science is, well, normal. It's the things scientists do, except in the times of revolution, those rare moments when a theory has to completely rework itself. And Kuhn argues that most of normal science is like a kind of puzzle solving. It's the act of taking a paradigm, say Newton's theories of motion and gravitation or quantum mechanics, and trying to extend them further and further into more domains, to tame further and further reaches of wilderness of scientific understanding and unruly examples, and bring them under the rubric of the paradigm. It's like an empire expanding itself into the countryside as it tries to assert its dominion over more and more areas which are outside of its control. Eventually, however, the paradigm starts running into problems. Its extensions and articulations eventually push it against what Kuhn calls anomalies. These anomalies are areas where nature diverges from the ideas of the paradigm. So far from being the meat of science, so many people believe that anomalies and areas where the experiment doesn't go as expected are the real meat of science, that what most scientists do is discover these anomalies and come up with new theories. Rather, what is happening is that for most scientists, these anomalies are actually a problem. So they're often postponed, pushed out, or ignored as long as possible, as long as the current paradigm can be maintained. And the reason why is simple, because for the person who encounters an anomaly, does it mean that they have found the key to overthrowing their current paradigm, or does it mean that they simply were a bad scientist and they simply did the experiment wrong, or they forgot to include some important deviations from the experiment that could be predicted if they knew more about it? So very often an anomaly is not evidence of some secret revolution that is about to happen, but simply that the scientist hasn't been a very good follower, a good practitioner of their own field. So what happens is that the crisis continues. It will continue that anomalies will pop up more and more, and like whack-a-mole, they continue to pop up even though scientists try to push them out and explain them away or box them out of the theory that currently exists. And in this process of multiplying crises and more anomalies popping up, scientists start to diverge. They start to experiment with more and more outlandish attempts to wrangle these new anomalies in with the theory, very often violating some or many of the key assumptions that were previously held to be dogma within the theory. So as they adopt stranger and broader methods for tackling the problem, they begin to depart from the paradigm. Essentially, the field starts to resemble a pre-paradigmatic state where you have many different schools, each with their own theory of how things work, and they all talk at cross purposes with each other as they try to resolve fundamental problems. Finally, however, there's a success. A new theory or paradigm explains the anomalies really well, and that other scientists are converted to this new way of thinking, and the revolution is afoot. If the new theory can be successfully pushed to encompass enough of what had been known beforehand, it may triumph over its predecessor wholesale. If it doesn't, there may be an interim period where you have multiple theories competing until one gains enough ground as to become the new way of looking at the world. So part of Kuhn's insight is that the triumph of one paradigm over another is usually not a clear matter, or at least not a very obvious empirical one. Each paradigm, by redefining and reorganizing the lists of concepts, methods, and even, heck, the validity of certain types of questions that you're allowed to ask within science, has its own standards of judgment. So invariably, a paradigm tends to view itself as being more successful by those same standards that it itself generated. So Albert Einstein, for instance, was stubborn in refusing to accept many of the ideas of quantum mechanics, even many of the ideas that he helped originate, because in blurring the line between measurement and reality, randomness and determinism, it was questioning fundamental assumptions about what science does. This wasn't simply the old physicist being stubborn, it was that he was right in saying that in his old paradigm, this new science was wrong, or it was wrong to think about science in that way. In his paradigm of science, there had to be such a thing as a reality that exists separately from how we look at it. And the stance of many new physicists that science is about providing answers to questions of experiments rather than positing some abstract reality that was out there that conforms to them wasn't simply a mistake, it was denying the very thing that science was. So realists, scientific realists like Einstein, believed that there was an actual fact of the matter, and our ability to decide or define the fact of the matter was quite separate from it. Whereas many later scientists, such as Bohr, posited a view that, well, actually what science is about determining the match between experimental observation and theory. And so whether the actual reality didn't fit that picture, or didn't fit some really cohesive account, wasn't really the problem. The problem was just simply, how do we match experiment and theory? So in this sense, the transition to the quantum domain, or the quantum paradigm, wasn't merely an issue of empirical fact. It was also a thing about what are the types of questions that science is allowed to ask? What are the types of questions that it should answer? What form should those answers take in order to be deemed scientific? So when Einstein and Bohr are arguing about these points, it's not merely that one is stubborn and refusing to accept the new reality, but rather that they have different conceptions of what science is and what its role should be. So earlier critics of Newtonian mechanics actually had similar metaphysical objections to the idea that gravity existed, it acted at a distance, but we couldn't really say, at least at the time, what it actually was. So this didn't seem to deny the idea of science. If you just posit these mathematical relationships, that ideas that matter attracts at a distance, this seemed to deny the idea that, well, is this even an explanation? Is this even what science is supposed to be doing? So at this point, it's worth pointing out that Thomas Kuhn is not a relativist. He's not arguing that all paradigms are the same and that all progress in science is an illusion and that it all boils down to matters of taste like fashion or music. It was very clear to Kuhn that science did progress, that Newton's mechanics are better than Aristotle's, that Einstein's are better even still. The question of this book is not to doubt our reality and say that science doesn't make progress and it's merely some cultural contraption that could be anything and it's anything goes. It's not to be this kind of postmodernist sophist and believe that it really doesn't matter in the end and you can believe whatever you want. Rather, it's to investigate that science does seem to make progress and how does it do it. And what Kuhn's main insight is that the standard model, or the standard view that science is this accumulation of fact to ever and ever better theories, was just wrong. That if you look at the history, that it had these periods of revolution where the very essence of what science was, the very essence of what was considered to be the correct kind of scientific problems to be solving, the areas where science was supposed to work and the areas that were supposed to be too complicated for us to get real actual solutions, was shifting in many of these instances. That there was an act of revolution and not merely a change of ordered scientific theories. So this is important. If science progresses and it doesn't progress the way that we thought it did, then what makes science special? What makes it different from art and fashion, which explode into new schools and fads and methods, but don't really seem to add up to anything resembling the triumphant progress that science embodies? So in some ways, Kuhn argues, this question itself might be misguided. We may be using a circular definition. Science may simply be pattern matched to those communities and fields which do happen to exhibit some kind of progress. So in Leonardo da Vinci's day, for instance, art and science weren't really seen as being that different. The fact that da Vinci painted, invented, and came up with scientific theories wasn't seen as belonging to two separate domains, but rather one overall practice of art and science. And this was because in Renaissance-era painting, representation, making a faithful match of how things looked in the world and translating that to an artistic medium, was held as the value that arts should be striving after. So once this norm was abandoned, once the idea that representation was not the only purpose of art, progress stopped and the family resemblance between painting and physics started to grow apart. Now, this isn't to dismiss non-representational artwork. I happen to love lots of non-representational artwork, but merely to pose that once this particular value, which we could approximate through ever and ever better versions, was denied as being the sole purpose of art, the sole triumph. Instead, you had many different schools of art, which each posited different values or different norms which they were trying to attain. And art started to become, as a whole, more fractious and divergent rather than science, where the goal of having better theories and better approximations of the truth and better predictive ability gets better and better over time because that value seems to be held constant. So science in this conception may simply be the category of fields which happen to show progress over time, rather than certain fields having progress because they are quote-unquote scientific. However, there does seem to be more than just science than this circular argument. It's not merely tautologically true that science is simply the things that do sciencey things. Within this perspective, Kuhn argues that it is the very way that normal science works, this puzzle solving, this application and extension of a paradigm, building off of the established true theories and extending them into further and further reaches, that those scientists, in seeking to confirm the paradigm of the day, are actually the ones who end up destroying it. That the success of normal science is that it fails. That the reason that science, in this process of trying to take Newtonian mechanics and extending it to further and further reaches, that this eventually sows the own seeds of its destruction and creates enough anomalies that someone like Einstein can come around and point out that it should be something different. So, in Kuhn's view, this alternative that we doubt all our fundamental premises and question the existing paradigm, this isn't the better path to knowledge. It's not the case that deep skepticism is somehow more wise and that questioning everything and not having any paradigm to go upon is the right way to achieve progress in thinking. Quite the opposite. It's only because scientists today have a great faith in the, let's say, standard model of particle physics that we could have invested billions of dollars to create the Large Hadron Collider and seek out the Higgs boson. Had every scientist had to doubt the foundations of their field and were coming up with new and novel theories, and new schools fought and bickered over what was the right fundamental premises with which to view the world, such impressive achievements in investigation, in experiment, in empirical work just wouldn't be possible. It wouldn't be possible for someone to devote their lives to, in academia, to a theoretical articulation of some particular sub-problem if a majority of scientists didn't agree that that problem was the correct one to be working on. So from this view, I need to state really clearly, Kuhn isn't arguing that because science doesn't seem to work according to the straightforward accumulation of knowledge that feels so obvious, that this doesn't negate science. Rather, he's trying to examine how science actually works. Given that it produces such wonderful results and that we do seem to know a lot more, and not merely in the way that we have a different paradigm than the old people before us, but that we are actually able to predict more, that we are able to engineer things, that we are able to do things that we couldn't do before in the old model. So it's this existence of progress that he wants to explain, and he's simply observing that it doesn't seem to happen the way that we might naively expect it to do. So this is important because many anti-science folks or critics of modernism have taken Kuhn to be this kind of relativist, this kind of person that says, well, because the transition between paradigms is not a purely empirical matter, that it's not something that just obviously happens because one is clearly better than the other, that there's a certain, it doesn't really matter which paradigm is in the case, and because each paradigm judges itself successful by its own idiosyncratic criteria, that really any paradigm is as good, and we should still be teaching Aristotelian mechanics as a viable alternative to Newtonian mechanics, and that we should be considering creationism in the same vein as evolution because, they're both paradigms and they both have their own ways of judging themselves, and really, who's to judge? This is not what he's saying. What Kuhn does show is that even if you accept the current paradigm, and even if you accept that accepting this paradigm is the only way to make scientific progress, it is nonetheless highly possible, and indeed likely, that revolutions may come which will completely reorganize the things that we currently believe we already understand. And I think this is a big point, that this revolution is not to say that the current process of science or believing what we believe is a bad idea, but rather that this is sort of our tentative best guess. And very often what happens is anomalies which seem like they are at the fringe, they seem like they are not central to the current paradigm, eventually end up reworking even the central examples of said paradigm. So suppose you're not a scientist, however. Suppose you aren't in the practice of doing science or philosophy or history of science or even caring that much about this kind of meta-scientific point. Why are these ideas useful for you in your life? And I think the idea of paradigms and the revolutions that they sow is far broader than simply talking about physics or astronomy or biology or social sciences for that matter. I think these are basic tools for understanding how we know things and how that knowledge undergoes shifts, and that is hugely important in our lives. So the first is in noting that in extending a current paradigm, even if it later turns out to be replaced by something that would render the current way of thinking unrecognizable, that this is the only way forward to learn things. This is the only way to make progress. That knowledge needs theories, it needs paradigms, it needs a basis point so that you can do the kinds of investigations and observations. That without paradigms, it's not the case that scientists are proceeding from a purely rational basis and they're working out the correct answers from first principles. But rather, without such a paradigm, it's not even clear what counts as an experiment. It's not even clear what kinds of things count as anomalies and what kinds of things count as something that's well understood. That without paradigms, the world is chaos. It's not some kind of ideal philosophical skepticism. So even when you are learning things yourself, you must form ideas, and then you have to look for the anomalies with those ideas and come up with your own versions of information revolutions, rather than having the idea that, I'm just going to be skeptical of everything, and therefore I'm going to be smarter than all these people who have bought into some esoteric theory. So Kuhn often argues that anomalies, places where your understanding of the world is different from what you actually see, will often build up for years. Scientists will still stick to the old paradigm until a new one comes to replace it. So that means that scientists can know that their theory is wrong for a bunch of things, but they will still hold to it for a long time until there is a suitable replacement. So this really points to the necessity of having a paradigm. The failure of their field doesn't cause them to abandon the sinking ship of an old paradigm until there's a suitable replacement to carry them onward. So in this sense, when you are doing your own learning, or you are trying to understand the world yourself, even in the simple ways that are not necessarily scientific, you have to have a starting point. You have to have the things that you currently believe, and you need to keep working on them. And until a new theory, a new way of looking at things presents itself, you need to keep working on it, even when that theory turns out to be wrong, or you know that it's wrong because it's giving you wrong results. So the second thing to realize is that knowledge often undergoes these kinds of revolutions. Total shifts where, although the same words and concepts may be thrown around, they come to mean very different things as they settle down on new positions. Kuhn points out that the concept of mass, which was conserved in Newtonian mechanics but convertible with energy in Einsteinian relativity, that the concept of mass, it's not simply that Newton was wrong about mass being conserved, but that what he called mass and what Einstein called mass tended to refer to slightly different things. The actual objects, the ontology, the things that exist in the world change subtly. That concepts which came to mean one thing tend to mean a slightly different thing in the context of a new theory. So you can think of it as sort of like a map in which there are concepts which represent particular puzzle pieces, and the normal work of science is fitting these puzzle pieces together to make a picture, and the revolution is a process of recutting the puzzle to look like it's different. So you may call pieces by the same names, but they tend to represent slightly different concepts. So the third thing to realize is that the new way of looking at things very frequently loses some of the beneficial advantages of the old way, at least in the interim period. So critics of the new theory are often correct because the old theory does seem to explain some things that the new one cannot. So if the new one is better, these issues are often forgotten over time that, well, actually the old theory did have an explanation for this and the new theory does not, and that this destructive capacity of the revolution is important. And I think this is important when we talk about non-scientific ideas, such as cultural revolutions in ideas or individuals changing their minds about things, that there is this destructive aspect, that the conservative critics, and I mean conservative in an intellectual sense, not in a political sense, but those who want to conserve the old theory or the old way of looking at things are often right in their criticism that it does seem to handle some cases better than the new way, that there are ways that you should look at things. And so I think that in this sense, it's important for the, again, intellectual progressives, the people who want to champion a new way of looking at things, to recognize that it is not simply that the old people are stubborn, but very often that they're looking at different problems as being central, that they're looking at a different type of problem as being the thing that science ought to solve or the thing that we should have answers at, and that this gestalt shift between what is in the foreground and what is in the background is very important in understanding who wins out in the long run. Kuhn's theories on scientific progress are a larger reality of the microcosm of our own knowledge in the world. We proceed on the basis of certain theories and ideas as we learn. As we keep learning, we encounter anomalies that break our conceptions of things until we reform, recrystallize at a new point with new ideas that can handle things better. In this view, the very tentativeness of knowledge, the fact that it's always possible that a new revolution will destroy or discard much of what we currently know, is always a possibility. However, and paradoxically so, we can't simply stop learning or question everything or doubt everything incessantly and still make progress. We need to accept certain things as being true and build off of them, even if future revolutions in our own thinking make these ideas wrong by some future paradigm. In my own life and writing, I feel like I've gone through the same process Kuhn describes with many of my ideas. I'll start with some idea of how life or the world works, and then problems begin to appear in the theory, which I tend to push aside. I push those aside as being not central or not the kind of thing that is easy to understand in anyone's view, my theory or someone else's. And eventually a new idea comes around that resolves some of those problems better than before, and I switch over. Those ideas, old ideas, are usually not entirely wrong, but in the new way of thinking, they're wrongly conceived. That's the wrong way of looking at the problem, even if the answers or the explanations it provide are not wildly mismatched with reality. In other words, the new concepts don't match up with the old concepts that were existing in my head. So perhaps you as well have experienced similar transitions. Maybe you resisted the exceptions and the anomalies to your thinking and pushed them aside, preferring to stick with the paradigm that you already know and already works for you. Maybe you continued down the rabbit hole and ended up with a different version of the world altogether, wondering how you could have been so wrong about things all your life. This view of knowledge and of science might seem unsettling. After all, if a future revolution will sweep away the current regime of things that you think you know about the world, why does it even matter? Why does knowledge matter? Why does the things I know have any pension or any purchase on the truth? Yet progress still happens. It's a paradox that keeps us going forward, even if it's not always in the directions that make sense to us. The Structure of Scientific Revolutions was our book for this month, and in my monthly book club. Each month, I read a new book, and I invite you to read along with me. At the end of the month, I'll post a recording or a discussion podcast episode like this one to share my takeaways from the book. I highly recommend reading at least a couple of the books, even if you can't always keep up with the one per month pace. I've been trying to pick books that I think are particularly important, not just because they're easy to read, but because I think they have the power to encourage the very kinds of revolutions in your thinking that Thomas Kuhn described. My hope is to expose you, even if you just follow the podcast, to some books that are a little different from the usual self-help and business books that populate bookshelves and bookstores everywhere. I think the effort you put into reading these can be well worth it because they can often provide the very revolutions in thinking that cause enormous downstream effects and allows you to solve many problems in your life, solve many puzzles in your understanding of the world that couldn't be resolved with your previous paradigm. Unlike science, which tends to proceed into the unknown given that no one has a better solution, as individuals, there are very often other theories that will explain and are better than the theories that we currently have that someone has already discovered and written down. It's up to us as individuals not to go out and do experiments and discover things from the world from first principles because no one has therefore explored it, but to read and to improve our knowledge on all sorts of topics, because very often a new paradigm will put into relief not just the problems that it contains, but it will creep out and cause changes in how you think about many, many other things. So next month in this book club, I'm going to be tackling a book that many of you will not agree with. Indeed, when I first encountered the ideas of this book, I was highly resistant, as these two formed an anomaly that I wanted to reject. However, much to my chagrin, the book is actually incredibly good. Extremely thoroughly researched, carefully argued, and backed up with enormous amounts of data. The book is Bryan Caplan's The Case Against Education, and I will be discussing it in next month's podcast. Thank you.